It's time to get your arrows popping. Ladies and gentlemen, this is Mr. Whitt from Fort Bend Tutoring, and today's tutorial is going to be about solving trigonometric equations part 2. That's right, you and I working on trig problems together. It doesn't get much better than this. And I prepare for you 5 problems, right, that we'll be working on today. You got number 1 with the cosecant of 3 theta equals -1. Number 2 is 2 cosine of 2x equals square root of 3. Number 3 is sine of x divided by 2 equals the square root of 2 minus sine of x divided by 2. Number 4 is 2 sine theta equals 2 cosine of 2 theta. Number 5 is secant of 3 theta divided by 2 equals -2. You see, we're going to have a party. All right, let's get into it. Here is our workflow, guys. This is going to be the strategy that we're going to be implementing in order to solve these problems. Number 1, we're going to read the directions and verify the possibilities of the solution. We're going to 2, isolate the trigonometric function if possible. Number 3, identify the domain and use substitution where applicable. Number 4, use inverse trigonometric functions to isolate the variable. And 5, we're going to ensure all solutions are in the correct unit of measurement. Amen, amen. It's going to be a fun time. I'm excited. I'm excited. You know what I'm saying? I'm ready to dig in. Let's go ahead and check it out. Here I want to remind you that Mr. Whittington never memorized the unit circle. I'm actually kind of proud of that fact, you know, but maybe I shouldn't be. But bottom line is, I need to use the special right triangles to help me calculate each of my trigonometric values. Therefore, I'll be referring to the diagram and the ratios of a 45, 45, 90 right triangle. And also I'll be referring to the special right triangle, the 30, 60, 90 right triangle and its ratios as far as helping me calculate the trigonometric values. Because once again, Mr. Whittington did not spend time memorizing the unit circle, and yeah, it doesn't matter that I teach this class. It makes no sense at all. But I chose not to because I like being defiant. So let's continue. So here we have our first problem with the directions. Solve the equation for solutions over the interval 0, including 0, to 360 degrees. And in number 1, we have the cosecant of 3 theta equals -1. So I'm noticing that there is a coefficient of 3 in front of my variable theta. And they've also defined our domain as being from 0 to 360 degrees. So the fact that theta has been altered in a sense with the scalar of 3 makes me want to change our conditions for the domain. So let's work on that first. We're going to show that we have our original theta being bound, all right, to being between 0 degrees and 360 degrees, right? And that's not what we have in our equation. What we have is 3 theta. Not just theta. So we'll need to alter our domain to accommodate the fact that it has this new scalar. So we're going to end up multiplying each value in our inequality here by 3 so that everything matches up with what we are expecting within our equation here. All right. So by multiplying everything by 3, guys, we end up with something familiar to us that's in the equation, right? The 3 theta. You see that in the middle of our compound inequality? Simplifying this, you'll have 0 degrees is going to be less than or equal to 3 theta, which is less than 1080 degrees. Amen, amen. And with this comes an opportunity to use some substitution. So that's exactly what I'm going to do. I'm going to tell the reader, aka my future self, my instructor, my classmates, that x is going to be equivalent to 3 theta. All right. So just talking to the reader to let them know what's going on because I just made up this variable. All right. So that's why I'm doing this. So now I can define that the domain for x is going to be from 0 degrees. All right. To 1080 degrees. So now that I have incorporated this new variable, we can rewrite the original problem. And we will show that cosecant of x is going to be equal to -1. Now using my inverse trigonometric functions, I'm going to isolate the variable x. So I'll have arc cosecant of cosecant x equals to arc cosecant of -1. All right. There we go. I hate that one. I'm going to fix it a little bit. Nope, 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 nope. Yes. There we go. All right. And so now that I have this set up, what's going to occur is that my arc cosecant and my cosecant will cancel out. So let's go ahead and kill those where they stand. And I'll be left with the variable x, which is now equivalent to arc cosecant of -1. All right. So what I'm looking for here, knowing that sine theta is equivalent to 1 over cosecant theta, which is equivalent to y over r. On the unit circle, I'll be looking for places where the value of sine is equivalent to -1, being as though cosecant is the reciprocal of sine, right? So I know that at 90 degrees, for instance, that our coordinate on the unit circle is 0, 1, and I also know that at 270 degrees, the coordinate on the unit circle is 0, -1. So as far as sine is concerned, I know that -1 occurs on the unit circle at 270 degrees. That tells me that the reciprocal of that value of sine, in this case -1, is going to still remain as -1, meaning that cosecant at 270 degrees is also -1. All right, so that's how I calculated that value. That said, we'll state that x is equivalent to 270 degrees because this is where cosecant would be equivalent to -1. All right. However, remember that our range for our value of x is spanning from 0 degrees to 1,080 degrees. And we're only at 270 degrees, which means that there is an opportunity to find some coterminal angles within this domain of ours for x that will also be a solution to our equation. In order to find out those values, what we'll do is we'll start off with our 270 degrees and we'll add a revolution to that, in other words, 360 degrees. That gives us 630 degrees, which is still within our domain for x, right? Because we have all the way up to 1,080 degrees before we're going to be outside of that boundary. So that means that 630 degrees is also going to be a valid solution for x for us now. Continuing this trend, we're going to add 360 degrees to 630 degrees. We're just going to keep going around that circle until we can't any further. This gives us a result of 990 degrees, which is once again within our domain for the value of x, right? Once again, going from 0 degrees all the way up to 1,080 degrees. We'll continue this with adding 360 degrees to 990 degrees to see if that's going to be within our domain for x. So adding this together, you're going to end up with 1,350 degrees, and that is not within our domain for x. So we will not be including that as part of the values for x, but we will be including the 990 degrees that we have right here. All right, so let's go ahead and continue on to our next page here, shall we? All right, so continuing our process, remember that we came up with 3 values for the variable x. And what are those 3 values? We have x could be 270 degrees. We have x could be 630 degrees. We also have x could be 990 degrees, right? And we're going to now back substitute in the fact that we stated earlier in the problem that our value of x is going to be equivalent to 3 theta. So replacing 3 theta for x in each of these equations, we'll have our first equation written as 3 theta equals 270 degrees, and then solving for theta by dividing both sides by 3, and then simplifying, we will find that theta is equivalent to 90 degrees. All right, so that's one of our solutions. Doing that same process for the other 2 equations will lead us to the following. We'll have 3 theta equals 630 degrees. We'll then divide both sides by 3. This will give us, after simplifying here, theta equals to 210 degrees, right? And then finally, for our last equation, we'll be substituting in 3 theta for x. We're back substituting, right? That's going to be equivalent to 990 degrees, divide both sides by 3. And once you simplify the left side of the equation, you'll have theta is equivalent to 330 degrees. So for our solution set for theta, guys, remember that original domain for theta was going to be between 0 and 360 degrees. Notice that all 3 of our solutions falls within that original domain for theta. Remember that theta cannot go above 360 degrees. In fact, it can't even equal to 360 degrees. It has to be between 0, including 0, and 360 degrees. So our solution set for this is going to be that theta is going to be equivalent to 90 degrees, 210 degrees, and 330 degrees. And this is going to be our answer here, guys. Red box it, people, just like that. There you go, people. That was problem number 1. How was that? Yeah? Pretty fun, huh? Let's keep it moving. And before we move on to problem number 2, I want to remind you guys that you can set up a paid online tutorial today with me, with Mr. Whitt. Yeah? Let's get our math on together, shall we? Just go to shop.tutormemath.net and set up an online math tutorial with me today, or fortbintutoring.com for that matter. All right. So I look forward to working directly with you. All right. Let's move on with our video here. We have in problem number 2, solve the equation for solutions over the interval 0 to 2 pi. Notice that now our unit of measurement is going to be in radians. So this is assuming that we're going to be in radian measurements from 0 to 2 pi. And we have the equation 2 cosine of 2x equals square root of 3. So let's go about the business of identifying our domain to begin with. We'll first show that our existing domain of x is going to be from 0 radians all the way up to 2 pi radians. So we have our original domain displayed as a compound inequality, right? Knowing that within our equation we have 2x, I'm going to adjust this domain. I'm going to multiply every value in my compound inequality by 2 so that I can match up the value that I'm dealing with in our equation. So anytime those scalars on our value of x are in play in our trigonometric equations, that's going to affect the domain. So now I'll simplify this to show that we have 0 radians is less than or equal to 2x, which is going to be less than 4 pi. And now using substitution, I'm going to tell the reader here, let theta be equivalent to 2x. And now going back to this compound inequality, I'll be replacing 2x with theta, guys. All right, there we go. And because I don't think in terms of radians, I'm going to make this adjustment here and show that theta is going to be between 0 degrees and 720 degrees. I'll now go ahead and rewrite my original equation. And this equation is going to be written as 2 cosine theta equals the square root of 3. And now, isolating the trigonometric function, I'm going to divide both sides by 2, like so. The 2's cancel out here on the left, and I'll now have cosine theta equals the square root of 3 divided by 2. And then I'll introduce our inverse cosine function. We'll have inverse cosine of cosine theta. All right, we'll have arc cosine, there you go, of the square root of 3 over 2. Okay, there you go, there you go. And then simplifying this, our arc cosine and cosine will cancel out to leave us with theta, which is going to be equivalent to arc cosine of the square root of 3 over 2. Now, the fact that my argument for arc cosine is the square root of 3 over 2, it shows that it's positive, and knowing that cosine is going to be positive in the first and fourth quadrants, right? I'm going to set up 2 triangles on my diagram to help me figure out what these values would be. So that said, I'm going to have this set up here. Go ahead and get this working for myself. There you go, there you go. Got a triangle working there. And let's go ahead and get an equivalent triangle in, get that going in the fourth quadrant. There we go, right? And then as far as our ratios are concerned, let me go ahead and plug those in. I'll have ratios of an x value that is the square root of 3. There we go. I'm going to have a radius or hypotenuse of 2 there. And then I'll also have a y value of 1 and a y value of -1 here. And what this shows me is that I'm dealing with a 30, 60, 90 special right triangle here, right? And with those ratios, I'm able to pinpoint the exact degrees that I'm dealing with. One being that I'm dealing with a 30-degree angle here for theta, and I'm also dealing with an angle of 330 degrees, all right? So these are going to be my initial 2 solutions that I'm working with. So let's go ahead and say that our arc cosine of square root of 3 over 2 is equivalent to 30 degrees, all right? And also it's equivalent to 330 degrees. However, keep in mind that we have a domain for theta, which is going to be from 0 degrees all the way up to 720 degrees, right? So let's go ahead and see if we can identify additional solutions to this, aka coterminal angles, that would also solve this initial equation. We can find it out by taking our initial solution of 30 degrees and adding 360 degrees to that. When we do that, we'll end up with 390 degrees. All right. Well, 390 degrees also falls within our domain for theta. Therefore, We're going to say that 30 degrees is going to work so far, 330 degrees is going to work, and 390 degrees is going to work so far. Let's continue. If we were to take our 390 degrees that we just got and add another 360 degrees to that, you would end up with 750 degrees. Well, see, the 750 degrees is outside of the domain interval for theta, so we can't take that. So therefore, we will not be able to use 750 degrees for this result. Continuing this process, we're going to look at the 330 degrees that we got as a solution and add 360 degrees to that. Well, this will end up giving us 690 degrees as a result, and that once again falls within our interval for theta. So this is another solution that we can use for our value of theta. All right, so let's go ahead and continue our process here, guys. Thus far, we have solved for theta, and our values of theta are 30 degrees, 330 degrees, 390 degrees, and we also have 690 degrees. All right, so these are our values of theta. Let's go ahead and set these values up knowing that theta was equivalent to 2x, right? So because of that, we now know that we'll have 2x equals to 30 degrees. We have 2x equals 330 degrees. We have 2x equals 390 degrees. We also have 2x equals 690 degrees. And then we will solve for each of these four equations to find out our value of x. So by dividing both sides by 2 and simplifying here, we'll end up with our first value of x being equal to 15 degrees. Then dividing both sides by 2 in the second equation, we find that our value of x is going to be x equals to 165 degrees. Then we are going to divide both sides by 2 in the third equation. This gives us a value of x, guys, that's going to be equivalent to 195 degrees. Elexo. Then we'll also divide both sides by 2 in our last equation. All right, that fourth one. Simplifying, you'll find out you have a value of x that is equivalent to 345 degrees, like so. That now means that we can continue this process. Why? Because they asked for solutions in radians, and right now we have degrees. So remember, this was a comfort zone for me, which is why I altered everything to degrees to begin with. But always keep in mind the units of measurements that the original question is asking you for. Whatever they ask you for, of course, you have to give them back to make sure that your solution is correct. So for me, I'm going to need to convert these all into radian measurements. And so for instance, I'll be taking the 15 degrees, and you can say that's over 1, and I'll be multiplying by my conversion factor of pi over 180 degrees. After simplifying, we'll find that x equals to pi over 12 once we have simplified this, knowing, for instance, that 15 goes into itself once and 15 goes into 180 degrees 12 times. So I'll continue this for each of the other three solutions, finding, in essence, that x also is going to be equivalent to 11 pi over 12. All right, that x is going to be equivalent to 13 pi over 12. And that x is also going to be equivalent to 23 pi over 12. All right. So once again, I took each of the degrees that I had and multiplied by the conversion factor of pi over 180 degrees. So my solution set will be written as x equals pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12 radians for my value of x. Amen, amen. Let's red box it, people. Done and done. And this is your solution for problem number 2, people. Alrighty. For problem number 3, they ask us to solve the equation for solutions over the interval from 0 to 2 pi. So once again, we're in radians, right? And our equation is sine of x divided by 2 equals square root of 2 minus sine of x divided by 2. So what we'll do here is, first of all, I want to get all of my trigonometric functions together on one side of the equation. So I'll start out by adding sine of x over 2 to both sides of the equation. So I'm adding sine of x over 2 to both sides of the equation here, like so. All right, let's get this looking organized for the people. All right, so now that simplifies to 2 sine of x over 2, guys, which is going to be equivalent to the square root of 2. All right. And I'm going to continue isolating this trigonometric function because I can now divide both sides by 2, right? So let's do that. We want to clean this equation up as much as possible. Simplifying, our 2's are simplifying to 1 here on the left side to give us sine of x over 2 equals to the square root of 2 over 2. And now we have it in a nice, concise form that we can utilize to work our problem out. Let's start with the domain of the initial function. We have it given to us that x is going to be less than 2 pi and greater than or equal to 0 radians. However, this x value is not what we see in our equation now, is it? If we were to have our 0 divided by 2, right, and the x divided by 2, and the 2 pi divided by 2, we can get a familiar form of the value that we see in our equation, and therefore adjust our domain accordingly. You'll end up with 0 radians is less than or equal to x over 2, which is less than pi once you simplify the right side of your compound inequality here, okay? We now can let theta be equivalent to x over 2 and use that substitution in our compound inequality for the domain by showing that we'll have 0 is less than or equal to theta, which is less than pi. And because of my handicap of being comfortable with degrees more so than radians, I'm going to adjust this to read 0 degrees is less than or equal to theta, which is less than 180 degrees. All right. This is my area of comfort, so I'll make the appropriate adjustments to the equation to make sure that I'm taking care of me, minimizing my level of stress throughout this process. Feel free to do so for yourself. Now I'm going to be rewriting the equation, and I'll have sine theta equals the square root of 2 over 2. And now incorporating my inverse trigonometric functions into the process, I'll have arcsine of sine theta is equivalent to arcsine of square root of 2 over 2. All right. On the left side, the arcsine and sine cancel out. I'll be bringing down theta, and I'll be looking for an angle, guys, that has a resulting ratio of square root of 2 over 2. That's what I'll be looking for. Knowing that this value is positive and that sine is the ratio of y over r, or the opposite over the hypotenuse, however you know it to be, I know that I can find this value in the first and second quadrant. So I'll be setting up 2 triangles for reference here. I'll have in the first quadrant, all right, the following triangle. Let's get that popping. And then I'm going to have a triangle in the second quadrant. Let's go ahead and set that up. Like so. Make it look nice and cute for the people. And then I'll have the following ratios involved, right? Knowing that these are my values of theta that I'll be solving for with the following ratios. Knowing that if I rationalize the square root of 2 over 2, by multiplying the numerator and denominator by the square root of 2, I'll have 2 over 2 square root of 2, which simplifies to 1 over the square root of 2. So I'll be utilizing these values for the ratios in my triangles that I have set up. Knowing that the y value is 1, knowing that the hypotenuse is the square root of 2, all right, I'll have an x value in the second quadrant of -1, an x value of 1 in the first quadrant. I know that I'm dealing with 45, 45, 90-degree ratios now because I'm familiar with those special right triangles. 45 degrees off of the x-axis in the second quadrant gives us 135 degrees, and 45 degrees off of the x-axis in the first quadrant gives us 45 degrees. So that means that my values of theta that I was looking for are going to be 45 degrees as well as 135 degrees. And notice that if I were to add 360 degrees to either of these values, I would be outside of the interval that I have for theta, which is going to be between 0 degrees and 180 degrees. All right, so let's continue our process here. So we are aware that theta equals to 45 degrees and that theta equals 135 degrees. And earlier in our problem, we let the reader know that theta was equivalent to x divided by 2. So back substituting here, we have x divided by 2 equals 45 degrees. We also have x divided by 2 equals to 135 degrees. And then solving for x in each of these equations, I'll be multiplying both sides by 2. So I'll have 2 times x over 2 equals to 2 times 45 degrees. And once these 2's cancel out on the left side here, you'll have x equals to 90 degrees for that first solution for x. In the second equation, I'll be multiplying both sides of the equation by 2 as well. like so. Thank you. The 2's are going to cancel out on the left side of the equation, simplifying to give us x equals 270 degrees, just like that. Now remember, our original problem was in radians, and we have degrees for our answers. Therefore, after converting these degrees into radian measures, you'll have x equals to pi over 2, and you'll also have x equals to 3 pi over 2, like so, guys. And so as a solution set for x, we're going to state that our solutions are pi over 2 and 3 pi over 2. Done and done, and let's red box it, guys, just like this. There you go. Red boxed it. All right, and that's problem number 3. Let's keep it moving. All right, and to remind some of you guys that you still have the opportunity to donate to Fort Bend Tutoring, because that helps us with our mission of helping as many people globally as possible. And the donation link, you'll find that in the description box and on the About page. We appreciate everybody that helps out with our endeavors. All right, let's continue. Here we have problem number 4. With problem number 4, it asks us to solve the equation for solutions over the interval 0 to 360 degrees. Our problem is to solve for theta, and we have 2 sine theta equals 2 cosine of 2 theta. Notice in our equation here that we have 2 different trigonometric functions. One is actually a double angle. And because of this double angle and the fact that this double angle doesn't match our sine theta trigonometric function, we may want to incorporate some trigonometric identities to help us with this process. Let's go ahead and do this. We'll use the following double angle identity, and that is that cosine of 2 theta is going to be equivalent to 1 minus 2 sine squared theta. That's right, we'll be utilizing a double angle identity. Let's get this all spelled out for you so you can reference it on your own. There we go, guys. And utilizing this double angle identity as well as substitution, we're going to be able to rewrite our equation. And we'll be able to rewrite it as 2 sine theta equals 2 of the quantity 1 minus 2 sine squared theta. Just like that. So notice that we replace the cosine of 2 theta with 1 minus 2 sine squared theta using our double angle identity. All right. That said, I'm going to get my arrows popping here. That's right. Get your arrows popping, guys, using the distributive property. And I'll rewrite the equation as 2 sine theta equals 2 minus 4 sine squared theta, just like that. And from this point, I want to go ahead and rewrite this equation in a quadratic form. So that means that I'll be subtracting 2 to both sides of the equation, as well as adding 4 sine squared theta to both sides of the equation. I'm going to try to do all this at once if I can, guys. All right. I'm going to try to do that to conserve space. And now I'll be able to bring down 4 sine squared theta plus 2 sine theta minus 2 equals 0. And I'll begin by simplifying the equation by dividing everything by 2. So I'm going to divide each and every term by 2. Yes, I will. Yes, I will. Just like this. Just like this. Okay, thank you. Divide each and every term by 2. Yeah. Simplify that thing, knowing that 2 goes into 4 twice. Yes, it do. These 2's will cancel out. Yes, they will cancel out to 1. Thank you. We'll rewrite the equation as 2 sine squared theta plus sine theta minus 1 equals 0. And we're going to now tell the reader, let sine theta equals x and sine squared theta equal x squared, and use this substitution in our process. Therefore, we'll have 2x squared plus x minus 1 equals 0. And factoring this quadratic trinomial, we'll end up with the following factoring pattern for this, right? You'll have 2x minus 1 times x plus 1. Setting each factor equal to 0 using the zero factor property, you'll have 2x minus 1 equals 0, as well as x plus 1 equals 0. Then solving for x in our first equation, I'll be adding 1 to both sides of the equation. Simplifying, you'll have 2x equals 1, then divide both sides by 2. Simplifying, you'll have x equals 1/2 as a solution for x. And then in the second equation, you'll subtract 1 to both sides, like so. Cancel out those 1's. You'll have x equals -1. So as far as our solutions for x are concerned, you'll have x equals 1/2, and you'll also have x equals -1. All right, so let's take this on to the next page. Keeping in mind that we told the reader that x was going to be equivalent to sine theta, we can now set up new equations that read sine theta equals 1/2, as well as sine theta equals -1. We'll go ahead and use our inverse trigonometric functions to isolate our value of theta, and you'll have arcsine of sine theta equals arcsine of 1/2. All right. The arcsine and sine will cancel out on the left side, and you'll end up with theta equals to arcsine of 1/2. So if we were to set up our diagram here in our first circle here, we'll show that the sine value can be positive in the first or second quadrants. So setting up my triangles like this. Let's get this going, people. Get it going, get it going, get it looking right. We got to show off for the customers that we have today. There we go. Let's get it together. And then using our ratio, knowing that sine theta is y over r, you'll have 1 for your y values. You'll have 2 for your hypotenuse here. And that third side is going to have a ratio of square root of 3. So in the second quadrant, the x value will be negative square root of 3. In the first quadrant, it'll be a positive square root of 3. And what does that tell us? That tells us that we're dealing with a 30, 60, 90 right triangle, guys. So 30 degrees off of the x-axis in the second quadrant is going to be 150 degrees. And then 30 degrees off of the x-axis in the first quadrant, well, that's just 30 degrees, right? So that tells me that my value of theta for this first equation is going to be 30 degrees as well as 150 degrees. Then solving for the second equation, we'll utilize our arcsine to solve for theta. Okay. So we have arcsine of -1 on the right side. Simplifying, the arcsine and sine cancel out to isolate the variable theta, which equals to the arcsine of -1. And then where on the unit circle will you find a value of -1 for sine? Well, once again, I showed you earlier, guys, that your coordinate at pi over 2 or at 90 degrees is 0, 1, and also at 270 degrees is 0, -1. So that shows me that my sine value can be -1 at 270 degrees. So for this value of theta, I'm looking at a result of 270 degrees. So therefore, as a solution set for theta for this equation, guys, theta is going to be equivalent to, we got to take our time with the braces because the braces are ugly, guys. We have 30 degrees, 150 degrees, as well as 270 degrees. And that is going to be your solution for problem number 4, guys. Red, box it. Let's go ahead and put this in a red box. There we go. Looking good, guys. Looking good with our red box for problem number 4. Let's keep it moving, people. Here we have problem number 5, guys. This is our last problem of the video. Has it been helpful thus far? I know I'm benefiting from this greatly, all right, because I don't do trigonometric equations every day. So therefore, every time I'm able to work out some, it's going to be helpful to me for my retention and also make me more comfortable when I'm teaching my students and my clients, all right? So therefore, I'm going to look at this problem, which is secant of 3 theta over 2 equals -2. And I'm going to begin with our domain here, guys. So with that, our original domain for theta is going to be between 0 and 360 degrees. Okay. And then because our coefficient on theta is 3/2 here, we're going to multiply each and every value in our compound inequality by 3/2. Just like this. All right. 3/2 times 360 degrees. There we go. There we go. There we go. All right. I think we got it set up now. Simplifying, you'll end up with 0 is less than or equal to 3 theta over 2, which is less than 540 degrees. And now that we have this, we'll go ahead and introduce a new variable. We'll tell the reader to let x equals 3 theta over 2. Going back to our compound inequality, you'll have 0 degrees, all right, is less than or equal to x, which is less than 540 degrees, like so. Now we'll go ahead and rewrite the original equation. We'll rewrite it as secant x equals -2. And incorporating our inverse trigonometric functions, you'll have arcsecant of secant x equals arcsecant of -2. And then on the left side, your arcsecant and secant will cancel out, isolating the variable x, which now equals to arcsecant of -2, like so. And you could also show that x is equivalent to the form of arcsecant of 2 over -1, knowing that the 2 represents the hypotenuse in this situation. The hypotenuse is always positive, guys. So that said, secant is negative in the second and in the third quadrant. So let's go ahead and set up those scenarios. And then our ratios for this is, we know that we have a hypotenuse of 2, that our x value is -1. So that means that our y value here would be the square root of 3 in the second quadrant and negative square root of 3 in the third quadrant, which tells us that we are 60 degrees off of the x-axis, guys, which puts us at 120 degrees in the second quadrant and also at 240 degrees in the third quadrant. So with that now known, our x is equivalent to 120 degrees. All right, and we know that that falls within our initial range of 0 to 540 degrees, and that our value of x is also 240 degrees, which also falls within our domain of x. But what we do need to know is whether or not we can find any coterminal solutions that will also fall within the domain of x from 0 to 540 degrees. We'll find that out by adding 360 degrees to the initial solutions that we got. So we have 480 degrees, which clearly falls within our interval for x. We're putting a check mark here, guys. And then we'll also add 360 degrees to 240 degrees to see if that will give us a coterminal angle that falls within our interval. This is going to be 600 degrees. Now, 600 degrees, guys, definitely falls outside of the interval that we have for our variable x. So we will not include this value in our process moving forward. So the values that are good to go are going to be the following. X equals 120 degrees, 240 degrees, as well as 480 degrees. These are going to be the values that we'll continue with in our process. Setting up our equations, we'll have 3. X equals to 120 degrees, x equals 240 degrees, and x equals 480 degrees. We told the reader earlier in our process that x was equivalent to 3 theta divided by 2. So let's do that back substitution now. We'll have 3 theta divided by 2 equals 120 degrees, and we'll have 3 theta divided by 2 equals to 240 degrees, and we'll have 3 theta divided by 2 equals to 480 degrees. Solving the first equation, we will multiply both sides of the equation by the reciprocal of 3/2, which is 2/3. So multiplying both sides of the equation by 2/3 will give us the following setup here, all right? And then simplifying this, the 2's cancel out, 3's cancel out. That gives us theta equals, and if you simplify the right side, you'll have 80 degrees. Doing the same process to the other 2 equations, in other words, multiplying 2/3 by each side of the equation here. All right, I'll show this step by step here, and then simplifying that will give you theta equals to 160 degrees for the second equation. For the third equation, you'll multiply both sides by 2/3 and simplify as we did in the previous 2, like so. All right, all right, all right. Everything cancels out. We'll simplify here, and you'll end up with theta equals to 320 degrees. So what I did was that 3 goes into 120 40 times, and I ended up multiplying 2 times 40 to get 80. In the second equation, 3 goes into 240 80 times, so 2 times 80 is 160 degrees. And then when 3 went into 480 160 times, 2 times 160 is 320 degrees. Notice that all 3 of these values fall within our original domain for theta, which was from 0 degrees to 360 degrees. Therefore, our solution for this problem is theta equals to, let's go ahead and get a brace going. Oh, that's an ugly brace. Let's get the brace going. That's a little better, guys. We have 80 degrees, 160 degrees, as well as 320 degrees. Close brace, and then let us red box it. Just like that, people. All right. And that concludes problem number 5 in this video, guys. All right. All right. Well, please remember to subscribe to the YouTube channel for Ben Tutoring. Go ahead and click that notification bell so that you'll be notified when we upload new and fresh content for you. And if you will, go ahead and leave a like for the video and communicate with me in the comments section, guys. It was a pleasure. Peace. Thanks for watching. We appreciate you hanging out with Fort Ben Tutoring. Like the video, comment, and subscribe.